Well, tweets have become the norm of government communication these days, whether we like it or not. Today, we've invited Jeff Shuren here from the FDA to dive much deeper than those 280 character limits. Join me in welcoming him to the stage as he shares with, oh God, you guys, jumping over my words. He's going to share with us the grand vision of the FDA. Thank you.
Good morning, everyone. Pleasure to be here. I have an apology. Technical difficulties, you won't see my slides. I will, you won't. Maybe they'll be available later time, but I will kind of talk from things. And my goal today, measure of success, is that my boss's boss's boss doesn't tweet about me at the end of the day. So I have the unenviable task of talking to you about regulatory oversight of digital health technologies. Yuck, right? And if not done right, can create a lot of problems. But if we've got smart regulation, then we assure that digital health technologies that are out on the marketplace benefit patients. That when issues arise, and issues will arise afterwards, that we can identify and address them quickly. There's consumer confidence in the marketplace, and we have a level playing field that's rational and predictable for developers, and that can help drive investment. And that's what we're looking at. Now, for us, software, and we're really talking about software involving medical devices, comes in three flavors. So we got software in a medical device, a component, software used to make a medical device, and software as a medical device. It really is the technology. And so software as a medical device, or SaMD, is the term in international parlance today, and that's really what we're talking about. And that's about software where it is intended for medical purposes. It's really not relying on a hardware medical device for doing what it needs to do. Now, we've got some challenges today because the regulatory framework that's in place for MedTech is not fit for purpose for SaMD. It's put in place over 40 years ago, and it was designed for hardware technology. It is stage gate. You deal with one thing and you move on to next. It's like going through the Panama Canal, one lock after the other lock. It does not work well for rapidly innovating technologies as we see in SaMD, and that's got to change. One of the other challenges we face in Washington, D.C. is there's a mindset among some that if you advance device innovation, it comes at the expense of patient safety. And nothing could be further from the truth. They're really yin and yang. If we can advance innovation to have safer, more effective technologies, or technologies that address a patient's unmet needs, and we prevent or mitigate the harm from their disease, that's about safety. And in the case of SaMD, if we don't allow for certain innovations to occur quickly, we put patients at risk. Cybersecurity, always have to be vigilant in making updates and patches. In addition, technology is interconnected. You change one part of that network can affect another part, and that SaMD may have to make modifications to stay current at the network, and if not, performance may be decreased, and that puts patients at risk. So I want you to imagine a world where we can trust and verify an organization's ability to make products consistently in a safe and effective way that gives confidence to both users and regulators. That's the world we're trying to move to. And this is a much more kind of a continuous evaluation loop, and it's got the following components. It starts with that evaluation of the organization, and we call that FDA pre-cert. You deal with that all the time today. We came through the airport, you've got TSA pre-check, right? They check you out beforehand, or if you're a good doobie, you get to move the line more quickly. They still take a look at you, but you don't have to take your shoes off. You don't have to do some other things. That's what we're talking about. In fact, we're going to call this FDA pre-check. In fact, it's copyrighted, so it's FDA pre-cert. That's how we got to the name. And we'll talk about this a little bit more in a minute. You link this up with a new risk-based approach that we developed. We led a working group in the International Medical Device Regulators Forum. It's with a whole bunch of other countries to come to a harmonized way to think about risk for SaMD, and it's based upon the functionality and the criticality of the disease that it's intended to address. And then based upon that, our idea is if we assess the organization, there may be questions that we typically ask on a product-by-product basis that we can now have answered in advance by looking at the organization. We don't need to ask them when the product comes through. So we could be looking at a streamlined review. We're still getting the answers we need in a different way. And then it's married up with a more continuous evaluation of real-world performance, looking at real-world data. That's where we think tremendous value comes from, that continuous learning loop that gets fed back into new modifications of the technology and new uses of the technology. That's what, in fact, we're developing. And so the goal is to try to move from an episodic oversight to a continuous oversight that enables trust in the organization and a pragmatic check-in with real-world organization and product performance data, that continual evaluation of the organization and the product, but doing this in more real time and having the product out on the marketplace. For us, the measures of success and our objectives here is, first of all, we're not changing the standard to come to market. It's still reasonable assurance of safety and effectiveness. But we think we can do this in a way that will improve the time for patients to get access to safe and effective technology, to improve the experience for developers and for the FDA, and to assure that a least burdensome approach is applied, answering the questions we need, but in the least burdensome way. To date, this pre-cert approach has been developed. We've got a working model that we created through multiple iterations with public comment, and we are in the midst of pilot testing it right now. So we have companies who have gone through one of these excellence appraisals, and we are now using that in the pilot for submissions. And the appraisals essentially are based on 5 foundational principles for excellence. This is on patient safety, product quality, clinical responsibility, cybersecurity responsibility, and a proactive culture, proactive surveillance, assessment on user needs, and addressing issues. And we didn't build this out of whole cloth. We looked at international standards, like from ISO. We looked at our own policies and those in the international community on quality management systems for software. We looked at Baldrige. We looked at appraisal approaches and maturity models that are used in other tech industries. And in fact, we have worked with the medical device industry to adapt it to them around product quality. We have now adapted that for SAMD very specifically. And what we have done is lined up and say, here's the questions we typically ask on a product. Here are the ones we think we could answer with this kind of excellence appraisal. And under the pilot, this is what you do. You send us the traditional submission you give us, right? Nothing changes there. But our digital health team takes that. They take the excellence appraisal, what we learned from it, how we would answer those questions, and they put it into the submission and they swap out all that extra data that the appraisal would address instead. They give it to the review team. They do a review, this streamlined review, with the goal of doing it in 30 days. And then at the end, they unmask it and they now look at the data that was taken away to see, would we have ended up with the same sort of decision? So product under the pilot still comes to market with the same data, same standard, same way, but we're learning about what may work in an appraisal model and how that could impact what we do and our expectations from the FDA, and how much we can sort of bake in advance, and what we could then deal with in the post-market setting. And for post-market, we're already building the models on leveraging real-world performance, looking at potential key performance indicators that would give us a window on continued organizational excellence. And for the past decade, we have been trying to advance the use of real-world data for med tech. 10 years ago, we started working with other collaborators to build new infrastructure like device registries and linkages to electronic health records and payer claims. We put out a strategy in 2012 for how we could leverage this data more systematically, how we can increase the value and use and decrease the time and cost of leveraging real-world data. We have branded that the National Evaluation System for Health Technology, or NEST. It is not an FDA system. It's actually owned and operated in the device ecosystem. It has an independent coordinating center, dedicated funding. Version 1.0 should be launched early in 2020. And the next piece is to start to link with data from technologies and patient-generated data. Already we have several data partners, almost 200 hospitals, almost 4,000 outpatient clinics. To date, will be in the very first version. Another thing that we've been working on is what about if that SAMD has machine learning? What do we do with changes occurring due to the learning of that technology? In April of 2019, we put out a white paper that laid out a proposal for how we might deal with it in a way that does not require coming back to the FDA every time you want to make a change, because that is not feasible, right? That's not going to work. So the idea is if we have good understanding and confidence in the data inputs, the methodology for validation and verification, essentially a change protocol, then we may be able to say, yes, you can move fast and you can move forward if this is what you do to expand the use of that product to these limits and not necessarily have to come back to the FDA and still stay in that continuing learning model. That's the idea. All right, so I've mentioned all the things about kind of oversight, but if this is going to work, think about it. You've got large amounts of data that are being reviewed and analyzed on a continuing basis. That's not going to happen with just people. So we essentially need AI to keep an eye on AI. And you heard from Amy Abernethy yesterday about ideas from the FDA. We are already investing in trying to build out our own digital transformation to have the capabilities to do that. And our vision for our reviewers in the future, here's the image I want you to have in your head. Our reviewers should be Iron Man. They should all be Tony Stark, right? Think about Robert Downey Jr. sitting there, and he's got the mask on, and all this data he can pull, he can ask about. He's got AI. He's got Jarvis, who's doing those analyses and then making recommendations. That's what we are looking to do at the FDA. So in the future, all of our reviewers would have a Jarvis. They'd also have a goatee as well. That's the idea. Now I mentioned if we're about maybe changing our model on not the standard, but the model and the framework for oversight, but this will require going to Congress to have it changed. We can't do this on our own. So you can imagine how long it's taking to sort of work this through of what to do, then go back to Congress and have the law changed. And this is not unique in the SAMD space, and think about it, we'll probably have to go back again and tweak it in the future. And then we've got lots of emerging technologies for which I've got an over 40-year-old framework that I'm dealing with, and that's problematic, right? If we have to keep going back to Congress. So what we're thinking about is something we call regulatory Legos, right? Could we instead have the building blocks to create new pathways based upon the unique needs of the technology, essentially so we can have the right pathway available for the right products at the right time. You don't want to build a train unless the tracks have already been put down. And you don't want to invest in building that train unless you know what the tracks are. That's what we have to do. So we have to have the ability to make those new pathways in near real time. But that will also require a change in the law to make that happen. Let me leave you with one last consideration. Another aspect we're dealing with is on human factors engineering. We deal with this all the time in medtech. And typically it's around, have you designed your technology to take into account how the users would interface with that technology? Are the buttons in the right place so that you're pushing the right things at the right time? And it's often focused on the physical. But increasingly with SAMD, it's interacting with us on the cognitive level. And what's the impact? We know for our children that if they grew up reading on more mobile technologies, their reading skills and their analytical skills are different from my generation's, for better or for worse. And it's now impacting how we think about educating children. So in the future, we shouldn't be addressing those questions so long after the fact. We have to be able to think about those and assess those on an ongoing basis now, the cognitive impact in SAMD. Because we will, in the future, we will have technology that's in us, on us, around us, that's interfacing with us, not just on physical, but just how we think and how we behave. So my question then, and I'll leave you with, is who will we be tomorrow? Do we want technology to change us and to drive those changes? Or do we want to decide who we want to be and design the technologies to help us get there? And those are the kinds of things that we're trying to do and to help to do at the FDA. Thank you very much.